All right, keep going. For this question, to find the limit of this expression, you need the basic formula. The limit of 1 plus 1 over n to the power of n when n is going to infinity is equal to e. Okay, now compare this one with the basic formula. Is that we have a problem here. The numerator is 2, not 1. So the first step I will do is dividing the 2 in both the numerator and denominator. And so it becomes this. And then I will change the variable. I will say n over 2 is equal to m. So of course the denominator becomes m. At the same time, according to this, n will be equal to 2 times m. So the exponent here becomes 4m. Be careful. When you are changing a variable from n to m, then the limit also changes. Originally as n goes to infinity, and now it is m goes to infinity. That makes sense because m is half of n. So when n goes to infinity, m goes to infinity at the same time. Now, how to evaluate the limit of this expression? Remember, we have this fundamental formula. So I will change this form a little bit and write it in this way. Inside the bracket, you see that the limit of the expression inside the bracket is exactly e. So you see that the limit of the whole thing here should be e to the 4th. Now, number 3. Show that the following series is divergent. To show a series is divergent, you can try to use the term test. That means if you have a series sigma an and the limit of the general term, be careful here. When we talk about the limit, I didn't put a sigma here. Do you see that? Okay, so if the limit of the general term does not exist or is equal to a non-zero number, then the series itself diverges. Now check this one. The general term is n over 3m minus 1. That's what we have for an. Okay? Remember, the notation an at different places has different meaning. In this case, an is just a general term. But previously, when we are trying to find the radius of convergence, an is just a coefficient of x minus 1 to n. Remember the difference. Okay, anyway, in this case, an is n over 3n minus 1, so the limit of an is equal to the limit of n over 3n minus 1, that is equal to 1/3, which is not 0, so the series is divergent. Number 4, find the following sums. For this one, it looks like a geometric sequence, a geometric series. Instead, but we have 2n as the exponent. We have this formula. The sum of a times rn, rn goes from 1 to infinity, is ar over 1 minus r. Maybe you remember it's equal to a over 1 minus r. That is because the index starts from 0, okay? So the first term will be a. Now, when n starts from 1, then the first term of the geometric series is ar. When n is 1, that's ar. All right, so the numerator is always the first term in the series. And the denominator is always 1 minus the common ratio, r. of course, we have a condition that if r, the absolute value of r is less than 1. When absolute value of r is greater or equal to 1, the geometric series is divergent. Alright, so come back to this. How can we write this series in this form so that the exponent becomes n? You can try to change this form of this general term into this way. -2 thirds squared, and then take nth power. And inside bracket, you see that it is equal to 4/9. Now, this is exactly in this form. A is equal to r is equal to 4/9. So according to this formula, it should be equal to 2 times 4/9, which is the first term in this series. Divided by 1 minus 4/9, that gives you 8/5. Next question. For this one, you just need to separate these two terms and take the sum of these two series individually. Be careful here, in the denominator we have a 4, so I took out this 4 as a 1/4. Now for this first one, it is geometric series, okay? So it's always the first term in this geometric series divided by 1 minus the common ratio. And plus, if you cannot see it directly, try to write down the few terms in this series. And you see that it's not the alternating harmonic series. It is the negative of the alternating harmonic series. So it's negative log 2. So just simplify it and you get this.